Okay, so in tutorials, you will get 1 mark for tutorial attendance, 0.5 marks for attendance and actively participate. That means you have to do the work by yourself. I will guide you. You know the theory because we have done the theory in the lecture, but I will help you to do the questions. If you have any question, you can ask. So you get 0.5 for that, and also another 0.5 marks every day for submitting the assessment to the weekly thing. If you were in the lecture, we went through all the 7 questions. Were you in the lecture? Last week, not this week, Tuesday. So we went through all the questions. So you already have the answer, so you can submit it at the end of the class. And at the same time, I want you to work by yourself. Here, it's very important to learn about materials. Why is that as engineers? Why we need to learn about materials? We start with the atomic level. We learn about different materials, the electrons, protons, and where they are in the periodic table, because we need to understand whether how they behave, how they react, or how they make bonds with other materials. And some are metals, some are non-metals. So all the elements that we have found so far are in the periodic table. So we are going to learn about it in the first module. And why it is important to learn about materials. Yes, so we are going to select materials for different applications. So depending on our requirements, we should be able to select the material. So same thing can be made up of different materials. Maybe this one can be, the table can make with wood, or else maybe metal. So depending on our capabilities and requirements, we have to select the best material. So not only the material properties, the economical, other customers' needs, we need to think about those things as well. However, in this subject, we are going to learn about, we're starting from the atomic level, and then first week is atomic level, and the second week we will discuss about, we already discussed about the crystal structures. And then we will learn when we heat up materials, what will happen. So every material, when we heat up, they have different states. So liquids will become solids, solids will become liquids, and some are becoming gases. So we need to know all the materials are not behaving in the oils, acting in the room temperatures. We sometimes need to use materials for space shuttles and other things as well. So materials. Yeah. Yes, yes. So we need to know about the phases. We will learn about the phase diagrams. Especially when you have one material, it is very easy to know whether at particular temperature, whether it is a solid or a liquid. But when we combine and when we make alloys, it's hard. Like, you know, depending on the composition, 50-50 or 20-80, the behavior of that alloy will be different in different temperatures. So we will learn about the phase diagrams, and then we will learn about the thermal properties, mechanical properties, optical properties, magnetic properties. So we will learn about different materials, how they behave under different environments. So it's really, really important. It's not chemistry. At the beginning, we have chemistry part, but when you go further, it's mostly the things that you can see by your eyes. So these atoms, electrons, protons, you don't see them. Even the crystal structures, you can't see them with the eyes. So, but when you go further, you will learn more about the things that you can look around and experience. And when you look at some things that made up of different materials, you will understand. You will see them in a different way than now after you get the knowledge. Are we good?
Yeah.
Do we know why we are learning this?
Yes,
okay, that's good. Okay, so the tutorial 1, we start with writing electron configuration. So this is your first question in the tutorial. They are asking us to find the electron configurations for some ions. So what do we mean by an ion and atoms? What's the difference between an atom and an ion? Atom has the same number of electrons and protons, isn't it? So they are neutral. They don't have any charge. So if you consider hydrogen, hydrogen has 1 electron and one one electron and one proton, isn't it? So one electron and one proton. So electrons and protons are equal in atoms. Neutrons can be different, but like they don't have a net charge. Ion means they have given electrons away or accepted electrons, so they can be in a negative charged ions or positive charged ions. So they are asking us to, in this question, we have to write the electron configurations of some ions. Fe2 plus, aluminium 3 plus, copper plus, barium 2 plus, boron negative, and oxygen negative. So before writing the electron configurations of ions, we should be able to write the electron configurations for the atom. So they haven't given anything to us, but if you look at the periodic table, I told you during the lecture, this is how we represent ion. Fe is the symbol. Hydrogen has H, and helium has He. So likewise we have different symbols for different materials, isn't it? So Fe stands for ion, and at the top you have atomic number, and at the bottom you have atomic weight. Atomic weight, and you have atomic number. What do we mean by atomic number? Number of protons or electrons. So in this atom, how many protons are there, or else electrons, both the same? Why is that? It has the same number of electrons and protons. It is neutral. And atomic weight is how many grams in a mole. Mole is 6.022 times 10 to the 23. It's like a dozen. I told you. Dozen of bread is 12 bread. So likewise, it's a number which is, mole is a number which is 6.022 times 10 to the 23. So atomic weight we'll talk about the atomic weight later. But we need this atomic number, or the number of electrons, to write the electron configuration. So Fe has how many electrons? 26. Am I right? So when you consider the atom, you have neutrons and protons here. So all the P's are here, and electrons are around the nucleus. So they are in shells, isn't it? So I told you, in shells we have subshells. So in the first shell here, in this first shell we have first shell has just one subshell, which is S, and the second shell has how many subshells? 2. What are they? S and P. And how about the third shell? SPD. Fourth shell, SPDF. So this SPDF is repeating. There is no after a letter after the F, because that is more than enough for us to write all the electron configurations for existing elements that we have found so far. So how many electrons can S hold? The maximum. So this subshell can hold 2 maximum electrons, up to 2. Okay, S can hold up to 2. P can hold up to how many? 6. D can hold up to 10, and F can hold up to 14. Okay, so this is the maximum number of electrons that these subshells can hold. When we consider these shells and subshells, some subshells are staying, like you can as you see here, as you see in this one, subshells are overlapping. So you can see this, I have written S, SP, second shell, third shell SPD, fourth shell SPDF. So likewise, these are the shells. But when the electrons, when you look at the energy levels, first energy level around the nucleus is shell 1, S. And in the second one, you have S and P, like this. And in the third one, you have SPD, like this. Okay, but when you consider the fourth shell, so you can, as you see here, P is after 3D you have 4p, so it's overlapping. So you can see how they are overlapping. So S is here, 2S is, this is 1S, this is 2S, this is 2p, this is then you have 2p, 3S, then we have 3p, then we have 4S. So 4S is staying in between here. So 4S is before the 3D. Do you understand what I mean? So they are overlapping. So because of the energy, so these subshells are staying according to their energy. So because of that, this 4S is staying in between 3p and 3D. So this shell will be filled before the 3D. Make sense? So to find it out, we have a pattern. We are using this pattern and we are dropping the electrons going like in this zigzag way, and then we will be able to write the electron configuration, even though we don't draw these shells and subshells in an overlapping way. If we follow this pattern, we will be able to write the electron configurations properly. Is that make sense? Okay, now let's see how we can write this 26. I will do one and I want you to do the rest of the things. Okay, now let's take the 26. How these 26 stay? So I am starting with 26 electrons. First I am dropping 2 here. So in 1s, first shell, S subshell, I can put 2 electrons. So this 1 stand for the shell number, S stand for the subshell, 2 stand for the electrons, number of electrons. Then when I cross here, I only have 24 remaining, isn't it? Because I have dropped 2 electrons at the subshell. So I'm starting with 24 and dropping again 2 electrons in the 2s. Do you agree with me? 2s, again I can drop another 2 electrons. Then I have only 22 electrons, isn't it? So how many I can drop at 2p? 6, because p can hold 6. Then I have how many? 16, isn't it? 16, I can drop another 2 in 3s. Am I right? 2 and 3x. So how many remaining? 14 remaining, isn't it? So then I can drop another 6 in here. Then how many remaining? 8. Is that right? And you can drop 2 in 4s. 4s, another 2. And then how many remaining? 6. So that 6 can be in 3D, isn't it? So the electron configuration for Fe is this. You can arrange it. So this is shell 1, this is shell 2. If you consider this is this one, it is your shell 3 and this is your shell 4. You can rearrange it in the shell according to the shell number. But you need to first write this, otherwise we will go wrong. Okay, so I'm going to write it properly now. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d6 and 4s2. Does that make sense? Now this is for Fe, but that's not we need to write. We need to write for Fe2+. 2 plus means what? How it become a positive ion. It should give 2 electrons away. If it gives 2 electrons away, then it will become an ion, 2+ ion. So which electrons it will be taking away? So it's always taking away from the last shell, even though this is filled before this one. Always when it is giving the electrons away, it gives from the last shell. So the last shell is 4th shell. Am I right? So this 2 will be going away. So if you want to write the Fe2+, that will be 1s2, 2s2, 2p6, 3s2, 3p6 and 3d6. Make sense? Are we good?
So that number next to the Fe2+, that actually just means that it's giving it one.
Giving two electrons. But similarly, if you have this one, if you look at Br negative, that means it's taking one electron from someone. Okay, plus means giving away electrons. Negative means it should adding electrons, because protons can't move. It is in the nucleus at the middle. Only the electrons can be changed. It can give away or it can take. Okay, so depending on whether it is a cation. Cation means positive ions, anion means negative ions. Depending on whether we have a cation or an anion, this we have to add or remove electrons. Make sense? Any question? No questions? Okay. Now I want you to do the rest of the things by yourself. So can you write down these ones? Aluminium, copper, barium, boron, oxygen. With the ions, okay? Aluminium 3 plus, copper plus, Ba 2 plus, Br minus, oxygen 2 minus. I'll give you the number. I'll show you the periodic table, and I'll give you time for you to write them. So did you write? When you finish, let me know. I'm going to move to the periodic table so you can start doing your work. So to get that 0.5 marks, you have to work in the class, not just the attendance, and also to the other 0.5 marks. So you get 1 mark for attendance, 0.5 for working, actively participate in the tutorial, and the other 0.5 is for submitting that assessment too. As I have told you, I don't want you to come up with all the right answers, but I want to see your genuine attempt. It's all for your benefit. Are we done? What's that? That's in writing. Okay. When you finish, let me know. Okay? Just you need to write, yeah, you can write down this, what we have done as an example, but the ones that you need to do are aluminium 3 plus, copper plus, barium 2 plus, boron minus, and oxygen 2 minus. Yeah, so first try for 13, okay?
Oh, you see, I was still taking it plus 3. So do I just it's like 10 instead of 13?
No, you first try for 13, because like, if you do that, you will go wrong here. When you are dropping, you will get wrong. So first you need to write without considering the 3 plus. So you have to write for 13.
Okay.
After you write it, then you take this one out after writing.
Okay.
Before writing, you don't think about how you do it.
Okay.
First you write. Yeah. Okay, so here also you have to first write for the Fe, okay, because in case if you consider Fe is 26 and Fe2 plus should be 24, and if you're going to write for 24, you get something else, because like, D is filling before before S, so you will go wrong. You first need to write for Fe and then look at the outermost shell. We call these valence electrons. They are the ones which go for reactions. So you take the electrons from the outermost shell. So first we write for Fe and then go to this one. Okay, are we done? Can I move to the periodic table? You're still writing?
Just keeping that.
Yeah.
If you have finished, you can do for aluminium. Aluminium has atomic number of 13. Okay, so write the electron configuration for aluminium, which has 13 electrons. You can write this one by yourself. You don't need, like, you know, S, SP, SPD. You can write it by yourself.
Yes.
Okay, so I'm moving to the periodic table. Okay, so here you can see the periodic table, and you, by looking at the number at the top of the element, so Fe has 26, aluminium 13, copper 29, barium 56, boron 35, oxygen 8. Just write these ones, okay? Later on we can make the ion. Just write the electron configurations for aluminium, copper, barium, boron and oxygen. Just for the atom, not for the ion. Later on we'll work for the ion. And when you finish, let me know, okay? Okay, so did you write for aluminium? So after you write the aluminium 3 plus means you have to take the last 3 electrons out. So last shell, 3 electrons, you need to take them out. Did you do that as well? Okay, so in the copper I need to tell you something. So leave the copper with me. And barium, let's write the copper. Can you tell me the copper configuration? What did you get for copper? Copper has 29 electrons. So copper is here. Tell me what did you get for copper? 1s2, 2s2, 2p6, 3s2, 3p6, 4d10, 4d what? Yes, 4d10, yes, then what? Last 4d9, isn't it? 4d9 and 3, sorry. Yeah, sorry, which 3d9 and 4s2, isn't it? So copper is bit different. Copper and chromium are bit different. Not only these two columns are different. So we need to understand why they are different. So you can see here for copper or else all of these ones. So if you look at here, 3d9, D is fully filled when you have 10 electrons, isn't it? So it would like to stay in the stable way. So when the D is fully filled, it is stable than having electron like this. So what copper does is that one electron from here is taken to the 3D and it will stay as 3d10 and 4s1. So that will happen to everything in this column. Make sense? So copper is a bit different. Same thing will happen to chromium. Chromium will be, if you write the electron configuration for chromium, that will be 3d4. Here you have 3d4. And you know D half filled if you have 3d5, isn't it? So what it does is you are taking one electron from S. So if you like for if you write for copper will be 1s2, 2s2, 2p6, 3s2, 3p6 and 3d5, 4s1. Do you understand the difference in copper column and the chromium column? So you need to do that when you do for copper and chromium. The rest are all the other elements. They will be the same like you did before. Are we good? Any question? Okay. So we are moving on to the answers. Okay, let's see what you have done and whether you got the right answers. Okay, did you get this for elements, the atoms? Did you get this? Okay, now see, when you consider aluminium plus 3, so you need to take 3 electrons, isn't it? 3 electrons from the outermost shell, so these 2 should be vanished, isn't it? You remove these 3 electrons. So how do you know whether you have the right number of electrons? When you count the number of when you count these numbers, you should get the right number, 13. If you have written it right, whenever you add all the top numbers, that will give you the number of electrons. So you need to take away 3 electrons. So if you remove this part which I have highlighted, that will be your aluminium 3 plus. So next one is copper just plus. So you have to take the electrons from the outermost shell, just 1 electron, copper, isn't it? And barium is 2 plus. You are taking 2 electrons away from the barium. And boron 1 minus. So here you need to add 1 electron. Am I right? So this will be 4p6. Make sense? And the next one, you have 2 oxygen negative. So you need to add the 2 electrons to p. So then it will become 2p6. Am I right? So did you get these numbers? Anyone have any question? No questions? No, can I move to the next question then? If you it covers all the electron configuration part. Next one is on bonding energy. So if you have any question, we can discuss here. Otherwise, we can move to the bond energy.
So just so I can confirm, just going to look at this.
Yeah.
So we write them all out, and then we sort them out into each of the numbers, and then depending on if it's plus or minus, we just add that and subtract that from the actual number, and that's it.
Yes.
Okay.
So and you have to add or remove from the outermost shell.
Yeah.
Yes.
From the outer motion. That's what after you arrange them.
Yeah, after arranging them. Yes, that's right.
Okay.
Okay. Are we good? Okay, let's move to the next question. Okay, next question is this. The net potential energy between 2 adjacent ions is this. So they have given you the energy between 2 ions. So when you consider 2 ions, so we have one ion and another ion. So they can't come very close to each other. Why is that? Ions can't come very close because they have positives, and positives will repel. Negatives repel. So it can't come very close to each other. Why it is not going away? If they have repulsions, they should go away like, in infinite distance. Why they can't go away, and why they are having a particular distance here? Because when you consider positives and negatives, positives here and negatives here, they have attraction. So we have attractions and also repulsions. When we have that equilibrium state, then they will stay like with an equilibrium distance between the 2 ions. Make sense? So when you consider this distance and the energy, so when you consider energy and the distance, we have attractive energies and repulsion energies. When you add both together, you will get a curve like this. I will show you the right curve that you have in the lecture notes. So this stable point, this is your R node, which is in the equilibrium, is getting when you have the minimum energy. In this curve, wherever you have the minimum energy, that represents the bond length in the equilibrium state. Make sense? So this is your energy equation. So you have a negative sign here. Attraction energy, repulsion energy. A and B are constants. Okay, so this energy is when you add these two energies together, you get the total energy. This is a curve like this. But they are talking about the equilibrium state. So they are asking, calculate the bond energy E naught in terms of the parameters A and B and N. The following proceeded. Differentiate. So they are asking us to consider the equilibrium state. Equilibrium means the energy is minimum. how do we find the minimum of a curve, minimum of a function from your maths? If you do the differentiation, how do you find the minimum point or a maximum point on a graph? First derivative is 0, isn't it? Why is that? What is the first derivative? First derivative of a curve is the slope, isn't it? When you go to a maximum point, what will happen to the slope? Slope is 0. Even when you go to a minimum point, slope is changing, but when it comes to here, slope is 0. So if you take the slope of a graph, it will become 0 when there is a maximum point or a minimum point. You have learned it in maths, isn't it? So if you consider the energy, if you take the derivative of this, when it is equals to 0, that means that will be your minimum point, isn't it? Do you agree with that? Okay, so now what we need to do is, they are talking about the equilibrium position. So we need to take the derivative of this. If you take the derivative of this and if you make this to 0, then you will get this corresponding R naught. Do you agree with that? So we are going to take the derivative of this. I want you to do this one. So how do you find the derivative of if you have xn? How do you find this? What is the derivative of this one? You remember from your maths? What's that? Is it this? Okay, so use this one and find me the derivatives of this one. Take the, you are not doing for dx. I want you to find this, okay? dr. Find this, please. Your n is, what is n in here? If you consider here, n is equals to -1, isn't it? And here, n is equals to -n. So, am I right? Can I give you a few minutes for you to think and do? And I will do if you can't. It's not materials, it's maths, so you can do it. Just try. Give it a go. If you can't, I'll help. This is what you have. En is equals to -a over r plus b over rn. And the equation that we have for dxn over dx is nxn minus 1. So a is a constant, so you can get a out of here. Am I right? So you have dr -1 over dr. Sorry, dr. If you take this, we need to do that, isn't it? So do you understand how I got this? So is this the same thing that we have? A, I took it out because why? A is a constant. Am I right? And then the next one, how can I write the next one? Plus, again, B is a constant. So I'm taking dr -n over dr. Did I do anything wrong? So this is, if I take to the numerator, it is r to the power -n, isn't it? So I have done something wrong here. This is -1. Yes, so this is -1. Are we good now? Is this right? So we need to take the derivative. So we need to take the derivative of different terms separately. Is this right? Have I done anything wrong here? I do mistakes, so you have to pay attention. I do a lot of mistakes. Sometimes I purposely do mistakes to see whether you are paying attention. Have I done anything wrong?
No.
Okay, so can you proceed? Use this equation here. Use this equation and write the next step. So what we need to do here, if you consider this first one, dr -1 over dr, what is n in this case? N is equals to -1, isn't it? So you put the -1 here. So you get -1 r -1 minus 1. Am I right? So this will be -1 r to the power -2. So this will be -1 over r to the power 2. This one, when you take the derivative, you get this. This part is becoming that. Is that right? Did you get the same? Okay, so that part is done. So I'm going to write negative. Negative will become plus, isn't it? So I can write, here I can write it as A over R squared. Do you agree with me? Next one is what? In that one, in the second one, what is N? N is negative N, isn't it? You put the numbers here. So N is negative 1. So in this one, you have to put negative N. So negative N X, negative N minus 1. Sorry, R. So this will be negative N divided by R N plus 1. Is that right? Is that right? So this will be negative N over R N plus 1. Is that right? Sorry, B also should be there. No? So B should be there as well. Are we good? So if you make this to 0 and if you find R naught, that will be the equilibrium distance between the atoms. Agree? So can you find me R naught, please? Okay, so this is what we had, minus A over R2 plus, and we had minus Bn over Rn plus 1 is equals to 0. This is what we had, right? So you can see the graph here. Repulsive energy is a positive energy and attractive energy is a negative energy. That's why you have this negative and positive here, okay? Now when you make this to 0, you can times by R. I'm going to times by R squared both these terms because I want to get rid of R in one term. So I have A is equals to Bn times R to the power 2 divided by Rn plus 1. So this is what I have. Is this right? Is this right? You have done your maths, right? So I don't have to explain those, I think. But if you have forgotten these simple things, let me know. We can go through. So do you understand what I did here? I multiply by the R squared because I want to get rid. Both the terms have R. So I don't want to keep R in both the terms. I want to get rid of R in one term. So what I did was I just times everything by R squared. Even this one also in R squared. The R squared will cancel out. So I have A minus Bn R squared over R1 n plus 1 is equals to 0, isn't it? Then I can say A is equals to Bn R squared over Rn plus 1, isn't it? Then I can say, I can take the Bn to this side. A over Bn is equals to R2 minus n plus 1. I can take this side up if I minus it. So I have R1 plus 1 minus n is equals to A over Bn. This R is my R naught. So if you want to make the R naught the subject, R naught will be equals to A over Bn to 1 over n plus 1. Do you understand this or not? It just maths, it's not materials, but you're just following, and you have an equation, you just find the R naught from that. Is it clear or not? You can do it by yourself once, okay? Later on by yourself. Do it once and let me know if you don't understand or if you get stuck. You need to do this part by yourself to understand the maths. And we are not going to give this kind of questions in exams. However, you have to understand these things. So that's why we have them in the tutorial. Are we good? That's what we have in the question number 2. But if you go to the question number 3, so in the question number 4, actually, we found these ones. Am I right? This is the finding of question number 3. So when the energy is minimum, you have R naught like this and E naught like this. In the question number 3, they are asking, consider the hypothetical X and Y ion pair for which the equilibrium interatomic spacing and bond energy values are given to us like this. So these two are given to us. E naught and R naught are given to us, and also if it is known that the n in the equation is 10, so n is given as well. Using the results of the problem in the previous question, determine explicit expressions for attractive and repulsive energy. They are asking you to find this and this, but to find these two, you need to know A and B. Am I right? So you have these two equations. You got this from the previous one. And you should be able to substitute all of these things in these two equations and find A and B. Do you understand the question and the steps to answer this? A and B are the only two unknown constants. So if you find the unknowns, you can just substitute it in these two equations and you can get an equation for EA and ER, attractive and repulsive energies. So you know that when you have two simultaneous equations, you can solve the two simultaneous equations and find two unknowns. That's you have done in maths, isn't it? So I don't want you to do this. This is a long process, but do you understand that this can be done if you substitute and if you solve the two equations, you will get that numbers. Is it clear? Okay, so I will show you the answer. You can try them at home if you like, you can see whether you get these answers. Okay, so when you solve the two equations, you get two values for B and A, and you can substitute them here and here. You get answers for attractive energy and repulsive energy. So attractive energy, for any distance, you can find the attractive energy, and for any distance, you can find the repulsive energy. If you know the R between the two ions, you can find the attractive and repulsive energy. So it can be anywhere in this curve. Make sense? So finding these two, you can try at home, but as I have told you, we are not going to give you this kind of questions in the exam. It will take time, but you should know that you should understand the steps. That's not materials, it's just maths, isn't it? Any question? No questions? Okay, I want you to try this, and your question number 3 in the 3 or 4 in your assessment also this, and I hope you have done it. Have you done that? I will collect it while you are doing this question. Did you do the assessment 2 weekly questions? Did you do that? Okay. So in that you have one question like this: finding the percentage ionic character. Am I right? So ionic, we can't say 100% all the bonds are ionic or covalent. What is the difference between ionic and covalent bonds? Ionic means what? There are 3 primary bonds. Am I right? What are they? Metallic, In the metals, you know, electrons will stay as a cloud. So that's why they are conductive. When you apply heat or else electricity, that electrons can easily move. Those are metallic bonds, and metallic bonds exist in metals. So do you know how to find metals here? The elements in the left-hand side of the periodic table are metals, isn't it? And the right-hand side, where you have a zigzag line here. It's going like this. Sorry, going like this. So these ones near here have metal properties and also non-metal properties. The ones here are metals, ones these side are non-metals, except hydrogen. Hydrogen is a non-metal, it's a gas. So all the other ones towards the left will be metals, and these ones are non-metals. So metallic bonds are there. And when you consider things from here and here, when they combine, for example, sodium chloride, mostly they are ionic. Why? Ionic means what? Ionic means what, guys? Tell me what do we mean by ionic? So if you look at sodium here, I told you in the lecture 1 why this periodic elements in the periodic table has meanings. So when you consider these columns, what that represent? Column number gives us what? Yes, number of electrons at the outermost shell. So you have 1 electron at the outermost shell here. Here you have 2 electrons. Here you have 3, 4, 5, 6, 7, 8, like that. Am I right? This is the D block. D is filling before S. So this is the D block, isn't it? So here, sodium and also row numbers. What is the meaning of row numbers? Columns. By looking at which column it is, you can identify how many electrons at the outermost shell. Does that make sense? And depending on the column row number, what you can understand? Number of shells. So this one has just 1 shell. This one has 2 shells, 3 shells, 4 shells, 5 shells, 6 shells, 7 shells. Am I right? So the row number gives us number of shells, and column number gives us number of electrons at the outermost shell. When the shells are fully filled, those elements are more stable. They can't react. So which column has the fully filled electrons? Which column is that? Outermost shell is fully filled, with the maximum number of electrons. Which one is that? Are you guys coming to the lectures or not? Were you in the lectures? Were you listening in the lectures? Okay, so when you look at here, this column are the inert gases. They are more stable because outermost shell is fully filled. They can't react with anything. So this is the more stable shell. But if you look at sodium, sodium has 1 electron at the outermost shell. How do we know that? Because it's in the first column. If this one gives that electron out, then the sodium will become stable. Am I right? So if this sodium gives an electron out and if it becomes Na+, that one is stable. Do you agree with me? Now if you look at the chlorine, how many electrons are in the chlorine outermost shell? 7 electrons. How do we know that? It's in the 7th column, isn't it? So chlorine, if chlorine can get 1 electron and becoming sodium negative, then it will move to this, the outermost shell will be fully filled. Do you agree with me? So these two would like to give, sodium would like to give an electron to chlorine, and chlorine would like to accept an electron from the sodium, and they would like to become sodium chloride. So this bond we call an ionic bond. Why is that? They are giving away electrons or accepting electrons. Make sense? So that bond we call the ionic bond, but to find out how much it is, sometimes we have mixed bonds, covalent and ionic. What do we mean by a covalent bond? Sharing electrons. For example, if we take methane, CH4. So carbon has 4 electrons at the outermost shell. Do you see that? Because it's in the 4th shell. So it has 4 electrons at the outermost shell. Hydrogen has 1 electron at the outermost shell. Am I right? So hydrogen has 1 electron at the outermost shell. If hydrogen can have another electron at the outermost shell, that S will be fully filled, isn't it? S has two electrons, so it will be fully filled. So hydrogen would like to share electrons with carbon and would like to make a covalent bond. And carbon would like to share electrons with the hydrogen, and it will become 8 electrons at the outermost shell, and it is stable. So now carbon and hydrogen both are stable, but here it is not an ionic bond, this is a covalent bond. Why is that? They are not giving away electrons, they are just sharing electrons. Metallic is a cloud of electrons around the nucleus, so it stays as a cloud and it is moving easily with electricity and heat, so that is why they are conductive. Ionic bonds are exchanging electrons. Covalent bonds are sharing electrons. Make sense? You have these questions in your quiz 1. So you have to be very thorough with these ones. Are we good? So percentage ionic character means how much of percentage is ionic. So maybe 70%, 80%. We can find how much is ionic. I told you there can be mixed bonds, covalent and ionic. So to find out how much of ionic, what is the percentage ionic character, we are using this equation here. So in this equation, okay, so you have the equation which is percentage ionic character. So percentage ionic character equation is 1 minus E negative XA minus XB over 4 100%. Is that right? Is that the right equation? I wrote squared. Okay, so you have a squared as well here. Squared. And also the electronegativity is X is the electronegativity. So electronegativity for magnesium is known 1 point. They are available. Okay, you can search and find it. Just Google search and find it. So these ones are given in your lecture notes, and for your question in the assessment you can use those numbers in the lecture notes, and I told you during the lecture you can use them. So 3.44. okay, so you know these ones and you just have to substitute and find the percentage ionic character. And what's that? What is that? I think it's 70 something, isn't it? If we all get the same numbers, I have to check. I don't have the answer here. Let's check all together. Percentage ionic character is 1 minus. It doesn't matter which one you consider, okay? Which one you consider, it doesn't matter. So 3.44 minus 1.31. Or else if you want to make it to 1.31 minus 3.44, that's also okay, because we have a squared sign here over 4. And you times by 100. Can we all do it and get the number answer? So if you all get the same answer, we are good. 60 something, 60, what was that? 60? 67, do we get 67 something? $73 roughly. It should be 73. Don't we get 73? Don't forget 73. Get 73.
So see, if we according to this table, I got 73, but the one you gave I got 66.
Okay. Yeah, mine something.
So according to this table, 73, according to you,
Tell me the right numbers, please. What is oxygen?
it's 3.5.
X oxygen is 3.5. Okay, your answer is right, 67. I think if you use the numbers in the 3.5 and what is the other one? 1.2. Yes, in the lecture notes we have a bit different numbers. Use the lecture note numbers. Okay, if you put this, you get I think to 73% something. So yeah, so 60. When you use the numbers I gave, 67 is fine. We use the numbers in the lecture notes. Okay, so this will be 3.5 minus 1.2. It is roughly 73%. Are we good? Any question? So you have this few of these ones in your assessment which you are going to submit today. Have you done that part? I'm going to collect it, okay? Just don't copy them. It's okay to go wrong. It's your genuine attempt, and also we are doing all that for you to learn. It's a compulsory assessment, just 1 mark, but you have to. Don't you think attending a tutorial is useful? Did you learn something today? Yes. So you attend the tutorials and bring those questions. Then I think if you watch the if you can attend the lectures, or else at least watch the lecture recordings, and I think this subject you can easily get a high distinction. Okay. And it is important as well. When we go further, it will be more interested than this. This is chemistry. So if you don't like chemistry will be there for only 2 weeks. Then we move on to the other parts. Okay, so that's all from me. We have only those questions. Do you guys have any questions? No questions? Okay, then we can wind up the class if you don't have any questions, and I want your assessment. If you haven't done it, just for the first time, you can email it to me, but from next week, I want you to bring the hard copy, and it is mentioned in the learning guide that we all have to stick with that. Okay, so for today, if you haven't done it, you can email it to me. From next week, I'm going to collect the hard copy. Okay.